Welcome to Science Hub. Today, we're diving into a fascinating study that explores the rising prevalence of chronic diseases in animals and how this phenomenon is intricately linked to both human health and environmental factors. Chronic diseases in animals, much like in humans, are influenced by a complex interplay of genetic and environmental factors. The study, led by researcher Antonia Mataragka from the Agricultural University of Athens, introduces a new evaluative model aimed at enhancing the monitoring and management of these diseases in animals. This model takes into account how human activities and environmental changes are contributing to these health issues. Genetics play a significant role in disease susceptibility, especially in animals subjected to intensive breeding for aesthetic or productive traits. This has led to higher rates of conditions such as diabetes and heart valve diseases in certain breeds. However, genetics is only part of the story. The environment also plays a critical role. Factors like poor diet, lack of physical activity, and prolonged stress are major contributors. For example, it's estimated that between 50 and 60% of domestic cats and dogs are overweight, which significantly increases the risk of diabetes in cats. In agricultural settings, around 20% of intensively farmed pigs suffer from arthritis. Human-induced environmental changes further exacerbate the risk of chronic diseases in animals. Urban expansion, climate change, and biodiversity loss increase the frequency and severity of harmful exposures. For instance, rising ocean temperatures and the decline of coral reef systems have been linked to higher tumor rates in sea turtles and fish. In urban areas, high temperatures and poor air quality contribute to increased rates of obesity, diabetes, and immune disorders in pets. Additionally, chemical runoff and air pollution impact the endocrine functions of birds and mammals. The study emphasizes the need to analyze and address these environmental factors to reduce the prevalence of non-communicable diseases among various animal populations. Mataragka's model blends the concepts of One Health and eco-health, highlighting the interconnectedness of human, animal, and environmental health. By integrating these perspectives, the model demonstrates how genetic predispositions intersect with environmental and social pressures to drive disease progression. The hope is that this integrated approach will support coordinated monitoring efforts across animals, humans, and ecosystems, aiding in the early detection of rising non-communicable diseases. By identifying common factors contributing to chronic diseases, researchers and policymakers can develop more effective strategies to mitigate health risks across species. This study underscores the importance of developing advanced surveillance systems for chronic diseases in animals, given their increasing rates. Understanding the genetic and environmental factors impacting animal health can lead to improved prevention and treatment strategies. Embracing a comprehensive approach that links human, animal, and environmental health might be key to addressing these growing health challenges. Such a deep understanding could pave the way for better policies and practices that safeguard public health and enhance the well-being of all species. Thank you for joining us today at Science Hub. If you enjoyed this video and want to explore more intriguing science topics, be sure to subscribe.